this is chapter 15, question 165. They want you to find the identity of x which can be converted into y in a single step. Now, if you look at the answers A, B, C, and D, the functional group of x is an alkene. Okay, because all of them, they have the CC double bond, right? A, B, C, and D. Now, in Y, there's no more CC double bond. Instead, you have the double bond, the cyclic compound broken into into an aliphatic compound like Y, and you have carboxylic acid and also ketone here. So how can you turn alkene into two different functional groups? And how can you break the double bond? Okay, the only reaction that you learn in A-level syllabus to break the double bond, okay, break open the double bond in the cyclic compound is to react alkene with hot and concentrated acidified KNO4. Okay, then that way, okay, you can break open the double bond. Okay, now if compound A is broken, okay, so it will be broken like this. Okay, compound B will be this, compound C, compound D. Now, if A is broken, I would like to number the carbon, so that it's easier for us to uh, check what happened to all this carbon. Okay, 7 carbon in A. Now, this is broken. So, carbon number 1, carbon number 2, okay, 3, 4, 5, and 6. Okay. Now, let me join all the carbon together. Now, I don't put carbon number 7 because it is actually bonded to carbon number 5. So, label again. 1, 2, 3, 4, okay, 5, 6. Now, one more dot for carbon number 7. Okay. Now, look, carbon number 2 and 6, they were sharing the double bond. Okay. Now, it is broken. So, carbon number 2, put double bond and then O. Now, for carbon number 6, okay, also double bond. Okay, but it's bonded to 1H here. So remember, turn this to OH. Okay, now let's see whether it matches Y in the question. Okay, yeah, we are lucky. A is the answer because the oxidation of A, okay, give us Y. So the answer is A. Now we can also check B, C, and D. Same thing, I'm going to number all the carbon. 1, 2, 3, 4, 5, 6. Okay, 7 here. Now the same thing, okay, because it is going to be, the ring is going to be broken, open. So 1, 2, 3, 4, 5, 6, it will become an aliphatic compound. So 1, 2, 3, 4, carbon number 7 is bonded to carbon number 4. So add one more here. Now I number the carbon again so that we can see what happened to each of them. So again, carbon number 2 and 6, they were sharing the double bond. Now it's broken open. Carbon number 2, okay, at double bond, then an O, 6 also double bond, okay, and OH. Now look at Y. If I number the carbon, okay, the 7 carbon, the methyl group should be bonded to carbon number 5 in Y, but here the CH3 is bonded to carbon number 4. So B is not Y. Now let's do the same for C. Now C, okay, we have 8 carbon, but you see Y only has 7. So C definitely cannot be the answer. Okay, we also proven B wasn't the answer. Now let's look at D. 1, 2, 3, 4, 5, 6, 7, 8. Again, 8 carbon. So D cannot be Y also. So the answer is A.